Programs in the real world deal with vast amounts of data, which can cause problems as more data means more complexity. Imagine how difficult it would be if you had to name a variable for every single post on social media. Now imagine trying to keep track of all those names and find a specific one when you need it. So as you can imagine, it's somewhat fundamental that we have ways to structure all of the data that our programs will need. Now, data structures are a mechanism in coding that let us group datums in order to get a handle on that complexity. Kind of like organizing your books on a bookshelf. Data structures let you organize the data in your programs to make it cleaner, faster, and more expressive. The main idea is that a data structure is a single entity in your code, that is, it can be referred to as a whole, but it also contains many individual pieces of data, which we can access individually when needed. So you can think of a data structure as an abstraction for all of its individual elements within. In this chapter, we'll learn how to group data together with lists, we'll learn how to map labels onto our data with dictionaries, and we'll look at the data in strings in a bit more detail. So a list is a linear data structure. You can think of a list as a bunch of variables grouped together into a line. You can refer to the entire thing as the list, or you can refer to the individual parts, known as the elements or items. When we put items into a list, the list will associate an ordering with each item, known as an index. So when we put items into a list, there's a first one and a second one and so on. Importantly, these indexes start at 0. A list is useful when you have data that you want to hold together, especially when that data is sequential or contiguous, like a list of student grades in a class or a to-do list of tasks that you want to complete one after another. For those already familiar with programming, you can think of lists like arrays, but there are some important differences that we'll cover. To create a list, the simplest way is to start with a list literal. This is a sequence of 0 or more values separated by commas enclosed within square brackets. The square brackets are what denote this thing as a list. Let's see some examples. So in Python, I could say mylist equals and then just 2 square brackets, and this creates an empty list. So I can say, what is the value of my list? And it's just those 2 square brackets. I could say the list of nums is 1, 2, 3, 4. Notice a number of values separated by commas enclosed in square brackets. And this creates a list of integers, and if I ask what's the value, it's just that list as we've seen it. So it's creating a literal list. Similarly, I can make a list of names. So with strings in there, I can say Alice, Bob, Charlie, and Dean. Notice each individual string still needs its quotes because they're themselves individual items. We're just grouping them together into a list. I can also say something like a list equals 1, the letter Q, the value false, and the number 3.4. And that's perfectly fine as well. So these lists don't have to have all the same type of values, although in practice, we'll usually have some consistency or similarity connecting the items together. We can have any number of values within these lists, and they can be of any type as well. In fact, the items within a list can also be other lists. We'll talk about this later on in this chapter. To access individual items from our list, or individual elements as they're called, we refer to the name of our list variable and then include an index in square brackets after its name. So if our list was named lis, L-I-S, then we'd say lis0 to access the first element from that list. So returning to our demo, we can see, we can look at the list as a whole. So we can say names and it gets the entire list, or we can talk about the individual elements inside that list. So I can say names and then index 0, and then names index 1. If I want, I can also say print names at 3. And that prints out the 4th one there. You might ask, why does computer science count from 0 instead of 1? The answer is a bit historical. In languages like C, where we use arrays instead of lists, the items in a list are stored contiguously in memory, that is, one after the other in memory. The name of the variable then just refers to the first item in the list. So to say the name of the variable at 0 means go to that name plus 0. If we say go to the name at 1, that means go to that first item and then go 1 item past that. If we say index 2, that means go to the first item and then go 2 items past that. This works differently in Python because everything is a reference, which we'll talk about later on. But historically, this is why we count from 0. If we want to know how many items are in any given list, we can use the built-in len function. So len, and then in brackets, we pass in whatever list we want to evaluate, and that will return the number of elements in that list. So we could say len of names, just the whole list there, and it gives us 4 elements back. I could say the len of nums happens to also be 4. I could say the len of this list here, which is just filled with zeros. So the len of some literal list, and it just counts the number of items in that list. We can also ask what's len of just 2 empty square brackets. And since that's an empty list, it has 0 items in it, so the len is 0. It's important to note that the indexes in our list go from 0 up into length minus 1. As I say, the last element in our list is at index len minus 1. So if I say the len of names, which has 4, and I look at the values in that list, so names, there are 4 elements in that list. And if I want the 4th one, I say the last one, I would say names at 3. Or another way of saying that is names at the len of names minus 1. Notice if I say names at the len of names, so in this case that's names at 4, this gives us an index error. That index is out of range. The values in this list are at indexes 0 through 3, 4 total items. So if I ask what's the value at index 4, that's asking for the value outside of a list, so we get an error. If you have trouble remembering or visualizing the relation between the length and the indexes, think if a list had 1 element, the length of that list would be 1, but the index of that value would be 0. So the last element in that list is at length minus 1. In Python, we can use negative indexes as a shorthand for using this length of a list minus 1. So I could just say names at minus 1, and that means the same thing. That's a shorthand for typing out all of the len of names minus 1. Those give us the same thing. Similarly, I could say names at minus 2, and that's the length of names minus 2, so it's the second last element. So using negative indexes counts back from the end of our list instead of forwards from the front. And notice if I say names at negative 0, that's just names at 0. There's no such thing as negative 0, so it just counts from the front again. Now lists in Python are mutable. Mutable means that the elements in that list can be changed without having to make a whole new list. So each element, you can think, works like its own variable. That is to say, it can appear on the left-hand side of an assignment operator. So I could say, for example, list at 2 equals the letter O, and then that changes the value at index 2 to the letter O, destroying whatever was there. So for example, if my list looks like this, I could say names at 0 equals Andrew, and now my list looks like this. So it replaces the value in that list. Notice the index must exist in order to be able to do this. So if I said names at 10 equals Jimothy, then it says index error, list assignment index out of range. So this 10 is out of bounds because we stop at 3 here, 0, 1, 2, 3. So index 10 would be over here somewhere. That's not a spot in the list, so we can't assign any values to it. We'll see later how to change the sizes of our list, but if a list doesn't have an existing value, we can't reference that non-existent value in order to change it. All right, so that's the basics of all the core operations on lists. So let's do a quick comprehension, make sure we understood all of that. So this problem starts out with a basic list called LIS that has the value 2468. The next line says list at 1 equals 5. So each one of the items in this list has an index, so we could write them out if we want 0, 1, 2, and 3. So if we say list at 1 equals 5, that means go into this list, add a given index, and change its value. The next line says list at 0 plus equals 1. So we go to list at 0, so that's the value 2. Remember, this is a shorthand for list at 0 equals list at 0 plus 1. So we take what's there and we add 1 to it. Next line says take list at 3, which is 8, take list at 0, which is now 3, multiply them together, so 24, and store the result at list 2. So we put 24 here. And the last line says print the current value of list, and since we kept track just in one spot, the current value is 3, 5, 24, and 8. And next we have a programming practice task which says write a function that accepts a list as an argument and prints that list 1 element per line. So returning to VS Code, let's say lists.py is a new file, and in this file we'll write our solution. So the task asked us to print each item from our list 1 line at a time. This is called traversing a list, or sometimes iterating over a list. So let's create a function. We'll call it def print list, and we'll take in some list as argument. So to traverse a list, we need to visit each element in that list one at a time. So let's create a variable called index that starts at the beginning of our list. And now we're going to repeat some actions, in this case printing the items in our list, once for every item in that list. So this index variable will start at the beginning of our list and will go up to the end of our list. So we'll have some loop, and the condition for this will be that index, so long as index isn't at the end of the list, so while index is less than the length of our list. So we'll say len of my list. Notice I said less than and not less than or equal to, because again, the last item in our list is at index length minus 1. So if it equals the length, then we've gone past the end of the list and we can stop iterating. So for each item in our list, we're just supposed to print that item. So I'll say print my list, and then I'll say at the specific index that we're currently at. So whatever the value of index is, we'll print that out. So the first time through, that's 0. Now let's make sure each time through our loop that changes. So we'll say index plus equals 1. Now the next time through the loop, it'll be index 1, then index 2, then index 3, all the way to the end of our list. So this function solves the task that was shown, but let's create a main function so we can run it. So I'll say def main, and this will just create a test list. I'll say the same one I used before, and then we'll say print list names. And then off in the global space, we'll make sure we start the whole process, and let's try it out. And it prints out each item in our list, one item at a time. Now, as I said, we can solve this using a while loop or a for loop, and technically a for loop is more appropriate because we know the number of times we want to repeat. Once for every item in the list, so the number of times we want to repeat is just the length of that list. So let's see how we can solve this using a for loop as well. So I'll create another version of this function, print list2, takes in some list. And now it's going to traverse our list just as the previous version did, but now using a for loop. So I'll say for I in range, the len of my list, and then just print my list at I. So it's much more succinct. The for loop is a bit more natural way of expressing this. So the index variable, we'll call I in this case, gets one value out of the range. Remember that range doesn't include its last value, so up to the length of my list, not including that last value, means the last value in this range will be the last index in our list. Convenient how that works out, one might even say intentional. So I is going to take one item from our range each time through the loop, which is going to be all the valid indexes for our list, and then we'll use those indexes to access and print one item from our list every time through the loop. So traversing a list is a very common pattern in programming. You very often need to do something to each item in the list. For example, print each item or mutate each item somehow, calculate some sort of totals or finding the largest or smallest items. We've already seen how to do this using a while loop, so we have some sort of index, and that index controls our loop so long as that index is less than the length of our list. Again, less than, not less than or equal to. Each time through the loop, we'll do something to the current item in the list, so the element that's indicated by the current index, and then we'll increment that index so that the next time through, we're on to the next item. We've also seen how to traverse a list using a for loop. So we could say for I in range, and then from 0 up to the len of list. And since we're saying from 0, we can actually leave that off and just say range to the len of the list, which again goes from 0 up to this value minus 1, so all the valid indexes in our list. And again, we just do something at each index in the list. Because the for loop is keeping track of the different values, we don't have to do any work maintaining that index. The loop does it for us, which makes our code a little bit cleaner and a little less error prone. Now, traversing a list is such a common pattern that most languages have a special syntax for it called a for each loop. A for each loop has the syntax of a for loop, so we say for some variable in some range, but now the range here, instead of using the range function, is just the list itself. And the value put into that variable is actually elements from that list rather than the indexes of that list. So returning to our example, if we wanted to print a list using a for each loop, let's make another version of our function. We say def print list3 takes in my list, and then we can just say for each. So for, I use a different variable, x or e. If you use I, it sort of suggests that it's an index, so I don't recommend using I here. X or e tend to be very common ones, or you can say element. These can be full variable names. In, and then instead of saying range of something, we just say the name of the list that we want to traverse, which in this case is called my list. And now each time through the body of this loop, the variable element will take one item from that list. So the first time through, it'll be the item at index 0, the second time through, the item at index 1, and so on. Noting that we don't actually have access to the index itself, just the items in that list. So if we wanted to print each item in this list, we would just say print element. And let's test this to show that it works the same. And we get the same answer. Notice in this case, even though we're printing out the loop variable, we didn't get the value 0, 1, 2, 3, 4, but the loop variable itself is getting the values from the list. So not an index, but the values themselves. Next up, let's practice traversing lists with a programming task. So it says, write a function that accepts a list as argument and returns the sum of all elements in the list. So we're given some list like 1, 2, 3, 4, we want to return the number 10. We've seen similar problems, but now we're involving lists, so let's see if we can solve this one too. So returning to our code here, let's make a new function. We'll call this one def SumList, which takes in SumList. Now you could call your name list, but that word already has meaning. So let's call it something slightly different. I'll just say lis. That's not a name that already has any meaning in Python. So we're given a list that we'll assume is full of numbers. Our goal here is to traverse the given list and sum all of the values. So we're gonna have to put all of those values into some sort of accumulating variable. So I'll call this total, and we'll start it at 0. Now we traverse our list, so we have many different ways, but the most natural way to traverse our list is just to say for some value in our list. And now each time through the list, x is going to be one of the numbers. So if we want to add that number to our sum, all we have to say is total plus equals, and then the value. When we're done, remember to return total. And let's test it out. So let's change main. Let's make a new list here called nums. This will have 1, 2, 3, 4 is a good tester. Don't need to test that, and we will test out SumList with nums. Save and run our code, and nothing happens. Now in this case, looking at our code, we started at 0, we summed everything up, and we returned total, which came back out to main. And since main didn't do anything with that value, we don't see anything. So let's also print our result here so we can see what happens. And in this case, it summed up the values from 1 through 4, which is 3 plus 7, which is 10. As an aside, we could also have just said, in Python, there's a built-in function called sum. We could just pass in the variable nums, print that as well. And that works just as easily. Note, that's why I called my variable in here total instead of sum, because the name sum already has a meaning. So that challenge wasn't too bad. Let's try another one. This one says, write a function that takes a list of numbers as an argument and returns a list that contains the squares of every number from the original list. So if we take in the list 1, 2, 3, 4, we should return the list 1, 4, 9, 16. So given some list, we're going to traverse across each element and square each one. So returning to VS Code, let's make a new function. So we'll say def, and we'll call this one square list, which takes in some list as argument. We'll call it lis. So if we want to traverse this list, squaring every single element, we can try this. We can say for le in list, le equals le times le. And then when we're done, we can just return the whole list. So this takes one element from the list, squares it, stores it back in the element, and then we return the whole list. So let's try this out. So we'll say print the result of square list on the variable nums. Save and run our code, and we get the list 1, 2, 3, 4. So our list is unchanged coming back out of here. So why didn't this work? Walking through our code, we created a list called numbers, which has the value 1, 2, 3, 4, and we passed that into square list. So lis has the value 1, 2, 3, 4, or the list 1, 2, 3, 4, and then we traverse through this list. So the first value here gets an item from the list, so le equals 1, and then it says le equals 1 times 1. So 1 times 1 is 1. Store that back in le. Le is still 1, so that didn't do anything. Hard to see. Let's go around to the next iteration. Le takes the next value from the loop, which is 2 from our nums. So on this one, we say then 2 times 2, which is 4, and then store that back in le. So le has the value 4. We go back up to the top of our loop, and we say now le has the next value from our list, 3. But notice we didn't do anything with the 4 that we calculated. So that math is gone, and we're on to the next value, which is 3. We say 3 times 3. We store that back in this variable called le, which is a 9 here. When we go back up, and that variable gets replaced. So the issue here is that we're not actually modifying the list at all. The variable Ellie is a local variable that's created inside the square list function. So it only exists within this square list function. And it's not part of the list, it's just getting its values from the list. So you can think of this as a completely separate variable that each time through the loop, we're going to copy one of the values from the list. So our list has 1, 2, 3, 4, but then Ellie gets the first value, which is 1. Our list still has 1, 2, 3, 4, it hasn't changed. The variable has copied one of those values. When we're in the loop, we can do all the math that we would normally do with variables that contain values. So we can say, grab the value of that variable and multiply it by itself, and then we can store it back in that variable. But when we go back to the top of the loop, it says, now that variable takes the next value from the loop. It's going to destroy any of the math that we did in the previous iteration because we stored that in this variable. So the issue is we're not storing it back into the list, we're storing it in this temporary variable, and that's immediately being replaced by new values. So I'll leave this in the notes here, but let's comment it out because it doesn't work. And let's try again. So we'll say def square list, sum list. So if we need to be able to put the results of our math, so the results of squaring these elements, back into our original list, then we need to know where in that original list we're storing these things, which is to say we need to have the index. So using a for each loop doesn't really apply in this traversal, so let's do just a regular for loop. I'll say for I in range, and then I'll just say the len of our list. Remember that's from 0 up to, but not including the length of our list. So from 0 to len of list minus 1. Now for each item in our list, I can just say list at I equals, and then we'll access that list and multiply it by itself. Another way we could write this is to use the exponent operation. So I could say list at I exponent equals 2. So let's save and test this out. And we get none because we forgot to return anything. So let's do that as well. Return lis when we're done. Run our code, and now we get the squares of those values. So to recap, when we're using a for each loop, we're copying elements out of the list, and then we're accessing a local variable that has a clone of those values or a copy of those values. Whereas if we're accessing these things directly, then we're accessing them in the list itself. So when we modify that location, we're modifying the list itself.